Just real quick, some of you may be a little bit new to Intel services. In fact, we even get asked this question even inside of Intel. Services in this context does not mean professional services. This is our web services business. So just for you to know, we actually have a group dedicated to that. So first of all, let me ask, how many people in the audience right now would say they're pretty aggressively tracking Internet of Things? Just show of hands, just a second. Okay, so roughly about a third. So in the next 25 minutes, I would like to think that I'm going to transform the thinking for the other 2/3 of the members in the audience and put IoT on your radar. You're going to find that whether you make devices today or not, IoT is essentially, as Oren talked with, is a new market. It's really a shift, the next computing wave, and it actually is going to ripple through and impact all of us here. So I'm going to kind of show you a little bit of a sneak peek. We actually have not kind of come out publicly in a big venue yet with where Intel sees this going, and I think you'll be interested in kind of this perspective of and spin that we're going to put on it. So first of all, IoT is already one of those terms similar to cloud computing that has many meanings to everybody. And so I'm going to try to minimize actually using that term. I'm going to just kind of bring it home and talk about really what's the shift, what's the paradigm shift, okay? So today, for 20 minutes, I'm going to just talk one concept, okay? One internet second is the essence of where we're going with IoT from a computing standpoint. And that's both a performance statement and a number of other aspects that I'm going to go into. So the rest of this briefing is just on this one concept, okay? I don't know how many, if anybody in the audience has had the pleasure of working in avionics in a former life. I did. This is actually the flight deck of the Boeing 787. I always like to actually start, even internally when I talk to my teams inside of Intel, a lot of groups will get talking about IoT, and the first thing I'll do is I'll put up a picture of a machine. It'll either be a manufacturing line, it'll be a flight deck, and I'll first ask everybody in the audience is like, do you understand how the machines work? Because this is the target market, right? IoT is not mobile reinvented. Okay, Internet of Things is about the thing. It's about the machines and how we actually now digitize and bring the power of internet connectivity to these worlds. The other reason why I bring this one up, first of all of us can identify with this. We all enjoy these once or twice or more times a week, more than I care to admit. I'm a passenger on one of these. A lot of people may not understand that in 1995 with the Boeing 777, this machine became software defined. On the Boeing 777, the avionics moved out of being low-level ASICs in chips, and everything that you see here is actually an application now. And down in the avionics bay in the aircraft are ruggedized servers. So if you actually went down into the avionics bay, you'd be staring at essentially what would look very much like a small little data center, ruggedized, running a common operating system, just like we are familiar with in mobile or in our desktop world, and applications that are actually controlling this system. The other interesting aspect for you to really kind of understand is you're roughly staring at 20 to 30 million lines of software, that is application software, and that software, those applications run begin to end in 1 second, and then it repeats. So the world of software, and for those of us who are technologists in the room, all that software runs in 1 second. There is no processing. There's one exception, is for the navigational type information. There's one background process that will actually go out to flash and retract the latest nav database because as the aircraft's moving, it's not trying to cache the entire world in the memory. But other than that, the rest of this runs in 1 second and repeats. And in fact, if you break it down, each one of these graphic symbols here on the display, each one of the, like the glare shield control panel, each one of those knobs, There's an actual process running dedicated to each one of those functions. And if you actually look under the hood in that world of 1 second, each one of those application threads that are running to serve every kind of control on here. So if you look at this, you should see basically hundreds of processes are actually running inside of the computers that are driving this system. And some of them are running actually 20 times per second, begin to end. Some of them are running 40 times per second, and some of them are running around 10 hertz, 10 times per second. So all of it adds up to the entire aircraft runs in 1 second and repeats. There's no CPU time beyond the world of 1 second. That's the machine world. If it actually turns out, if you go into a Honda manufacturing plant and you look at the robotics and you look at the production line, the entire factory actually runs in 3 tiers. The robotics control are applications that run 1,000 times per second. The orchestration between multiple robotic arms moving is typically an application that runs 100 times per second. And then orchestrating moving the actual production line runs at 10 times per second. So the entire factory runs in a second and is repeating. Until you get to the operations center and where the humans are actually watching the operation, everything below that in the machine world is running at that pace. So the question, the reason I mention this, is now the question is can we leave the fuselage of an aircraft and can we run the Internet of Things the same way? Okay? So can we expand this to cloud scale? And the answer is yes. Now what's interesting is when you really start to look at some of you in the audience here, your businesses are already kind of getting there. So we're actually not as far away from this as one would initially think. This is, I have to give it up to AT&T. This is actually a picture of AT&T's latest cloud data center. And I've actually been in it. This is a static picture. You can imagine if you're in it when it's live, the amount of data and how it's changing in real time. What's really interesting is you're looking at the flight deck of an enterprise. I really loved it when I walked in here because it's like, wow, you can actually feel the scale and magnitude of an enterprise and everything that's happening. And in fact, if you actually look at some of the largest APIs that are being delivered out there today, easily up to 9 to 10 billion API transactions now at the web services level being invoked per day, which equates roughly to 100,000 API transactions per second, if you do the math. And obviously, in the financial trading market, everybody, people who track kind of infrastructure in a financial trading market, they're already down to now 1 millisecond is critical in financial trading, in stock trading. It literally 1 millisecond can translate into millions of dollars where the buy or the sell order gets processed by your competitor 1 millisecond faster than you're selling or buying at a better price. So we're already kind of there from a transaction standpoint of just how massive and what is happening in 1 second. Now, I'm going to show you some things. You're going to go, whoa, this seems like this is science fiction, and we've all watched some Hollywood movies where there's been villainous networks or villainous robots run wild, and we all think that kind of performance and connectivity is science fiction. Well, it's actually not. And if you actually peel away and kind of abandon the IT stack a little bit and look at the infrastructure underneath of the IT software stack, you will be amazed to find out kind of where we're at from a capability and what we've built out. So under the hood today, first thing is I'm a software computer science graduate working for a silicon chip company, and obviously there's a lot of software involved in that business. But when I talk to my hardware colleagues, for instance, the first thing is when I describe kind of where things are going is some people don't understand. If you're not a software engineer, you don't necessarily understand just how much software there is in the world. The whole saying software is eating the world. Well, depending on how you measure it, and this is actually conservative, we're now looking at 1 trillion lines of operational code in the world today. And the first thing I'll tell our developers is before you write one more line of code, you have to ask, is there something out there that already does an 80% solution instead of sitting there reinventing it? And if you actually move into all the web pages that are generated right? A lot of the content in the web page now is actually generated. It's JavaScript, and so it's generated code. And every time you come into a web page, and that web, in fact, I was just shopping for a digital camera just 2 days ago, and I mean, literally, the next day I started going to CNN and some other websites, and all of a sudden the cameras I'm looking at are popping up as advertisements. Well, obviously, what's happening is that data of what I was doing and where I was shopping is now being pushed to CNN, and CNN's kind of getting a kickback for advertising that not only the camera, but where I was shopping. It was their advertisement, right? So that web page is actually being custom generated for me. That JavaScript is being generated for me in that content. So each one of us now is essentially getting a personalized web experience. That's a lot of code. So if you actually count generated code that's happening tied to each one of us and our social patterns, 10 to 20 trillion lines of software out there. And it's dynamic. It's actually being generated. So a lot of software. Other thing to understand, your best of breed, top of rack, enterprise Ethernet switch, when we get the performance, we're now down to 200 nanoseconds port latency. So data coming in a switch and then being routed out of the switch, not routed, but switched out of the switch over Ethernet. We're now down to 200 nanoseconds. If you talk to the big network players, they will tell you that in 5 years that's down to 50 nanoseconds, and in 10 years we're down to single-digit nanoseconds. We're almost down to speed of light processing in the switch with almost zero latency. So what that means is from sending data over the network, especially in the wired world, we're getting down to where it's only physics. It's only speed of light. And cumulative latency has almost become a non-issue. So that's powerful. And how that actually boils up is even today, I actually verified this even in London. For the entire city of London and the outlying areas, I can sign a contract today guaranteeing me, and I can buy 10 gigabit Ethernet fiber optic links, and the company will guarantee me that latency will not exceed 3 milliseconds from one extreme end of London to the other extreme end of London. Just for you to know, that's slow enough latency that 1/3 of that aircraft that I showed you, I could do 10 hertz control loops, machine-to-machine control at city scale. So I can run the city like 1/10 of that, or 1/3 of that aircraft. That's where we're at today with networking. It actually turns out even over LTE and 4G, 4G plus type networks, we're now looking at roughly about 50, depending on how close you are to the base station antenna of the subscriber ID, we're now looking at 15 to 25 milliseconds latency to leave your cellular subscriber ID unit and get to the cellular base station in the tower. It's one RF hop, and it actually turns out in most populated areas, that's the only RF hop you do, because from the minute you hit that base station, you're in the wired world, and the cellular infrastructure is all connected over fiber optics on the back end. So again, really tight latencies. So let's just talk Internet of Things a little bit more, because again, I come from a pretty extensive, I'm kind of the confused engineer. I kind of came from I started out in big IT. I switched tracks and spent the next half of my career in the machine world doing a lot of hybrid architectures. And it's really important to understand these are the use cases of IoT. IoT is not mobile reinvented, okay? IoT is how you actually bring digital technology to these kinds of use cases. So I'm going to start with the one that we're all kind of familiar with and kind of take it to more extreme. So in the retail business, where they would like to go just as a new experience from a human to a shelf experience, right? Or human to the thing sitting on the shelf, is they want you to be able to walk, and with your iPhone, instead of having just a little piece of paper on the shelf, to be able to just walk and have what you're looking at just pop up on your mobile phone. So you have a digital signage as you're walking through the retail store. Well, to be able to do that, the slowest anybody will tolerate of that is roughly around 250 milliseconds. Slower than a quarter of a second, and I'm having to slow my pace of walking through the store to actually wait for the push of the web services and the APIs that are actually giving me the context of where I'm standing in the store to what I'm looking at. And actually, ideally, you actually want to be that twice as fast. You basically want close to 1/8 to 1/10 of a second speed for you to just be able to naturally walk and get digital signage as I walk, okay? So that's quarter of a second world. We actually walk it, depending on how fast. Some of us are slow walkers, some of us are fast. We generally walk at 3 to 3.5 miles per hour. And actually, the function of human motion, once we start having exoskeletons, which are being developed, obviously for medical reasons, they're already there. The function of actually moving my arms and my legs at a walking pace is a 5 millisecond latency process. If it's any slower than that, you're holding me up, and my body is going to recognize that something is obstructing my natural motion. Networked robotics, if you look at Kiva robots, which are being heavily used, for instance, within Amazon fulfillment centers, where you're actually sending robots out that are actually bringing the shelving to the fulfillment operators that are loading the boxes with your orders. To be able to actually do effective networked robotics, you're looking at roughly 50 milliseconds. Maximum latency is needed in order to actually push data out in those use cases. Obviously, autonomous car, you're looking at roughly 25 milliseconds to be considered safe for an autonomous car to be able to respond to events that are happening nearby with surrounding cars. In the case where, right now there's a lot of fanfare around wearable technology and so forth. It actually turns out that if you're actually going to ever be able to use something you're wearing as a clinical device that a clinician is actually going to take action against, at least in the US with the FDA, any life-critical alerts, such as you're having a heart attack, you have to prove that event can be sent and processed in 10 seconds or faster, or it cannot be certified as a medical device. So 10 seconds is considered to be life critical. Anything slower than that, it risks your life, and clinicians cannot respond fast enough. So we're really getting down to machines as a service, right? And what I love about this picture, this is actually like a future look at a future operating room. There's over 250 devices in here. So if you do want to, for a second, think about a mobile paradigm, right? Think of 250 devices, and how do I build apps and automation for this? The other key aspect to understand for Internet of Things is, some companies are just focused either on the things side of the equation. Some companies that you read about are kind of more data center oriented or server side. It really is about how we tie from the things through the network to the servers, how we bring all that together, right? And so what you'll see coming from Intel is we're very much going to be focused on each of these aspects, because it's about how we create that horizontal that allows that device-to-cloud connectivity that Oren had mentioned. I'm actually going to skip this one and just touch on it really quick. There's really kind of 3 stereotypes in the marketplace of how people are thinking about this. There's kind of like the home enterprise IoT side of it. That's more the conventional, original, kind of what I would call Generation 1 IoT. The mobile players and so forth obviously are looking at IoT as a form factor play. So they see IoT as just different form factors of mobile reinvented. So how do I put something on a small watch display, or how do I put something in a car dashboard? The really exciting part, what I'm talking about here, is actually what we're calling the era of software-defined machines. So if any of you have been tracking software-defined networking and the revolution that's coming in software-defined networking, this is software-defined machines. This is a rethink of how you actually build applications for this kind of the world, right? What others are calling the industrial internet. So real quickly, there's going to be a new term that you're going to be hearing in the marketplace. It's kind of a little bit hidden right now. We all witnessed over the last 10, 15 years the revolution called voice over IP, right? When you look at how we get our content now, we only dreamed about that 10 years ago. Our music, our movies now is coming over IP. We can conference and game over IP. Well, there's a new convergence wave that's coming, and there's even a new standard in the Ethernet body that's actually now going to be bringing machine control. So real time, and I mean hard real time, machine-to-machine messaging is now being added to the Ethernet standard. So what this is going to allow us to do in the next convergence wave is actually bring essentially robotics control and be able to run deterministic robotic control right in the same enterprise networks that are carrying our voice and our data. So I'm going to ask you a key question here. So here's an interesting perspective. In the last 20 years, every one of us in the room, individually, depending on how heavy of a user we are and how many electronics we use, there's between 500 million and 1 billion lines of code supporting each of us in this room. So just think of it, tethered to us right now is we're backed up digitally, the digital us, between our LinkedIn, our Google, our emails, our mobile apps, and so forth. You add up all the software of all the services and all the web services that support each of us socially or in our professions. We're digitally automated and supported by 1 billion lines of code. We've done great for us, but for Internet of Things is about everything else, right? So here's something interesting. You go into a hospital, and your life is at risk in being managed by clinicians. There's roughly 5 to 10 million lines of code to automate your life. So we've done great socially. We've done great in the enterprise world. But the minute a machine is involved, right, we haven't actually done much to digitize the rest of the world. So what if we could? So today, if you actually look at a healthcare monitor, it's essentially, there's actually over 500 sensors that can be put on a human body. At any one time, the big monitors will support up to 32 concurrent sensors on you. So there's over 500 types. And then when you're in the intensive care unit, up to 32. And essentially, there's one dedicated app. There's about between 2 to 5 million lines of code embedded in that device. And essentially, it's an oscilloscope. So what we're actually giving clinicians are voltage regulation, voltage signals of the sensors on your body. And we're giving them bumps in the wire, and they're literally masters at looking at oscilloscope readings of body sensors to predict and manage your health and your state. Wouldn't we all like to get more back to like the flight deck for health, where you can actually have a control panel that actually gives you real live analytics of what's been happening to me? Shouldn't we be lifting the clinicians up from just being low-level technicians that are reading oscilloscope readings and give you more of a real-time analytics dashboard of your health state, and even have it be have soft clinician apps that are actually doing predictive medicine on you and to be able to personalize it? Well, to be able to do that, I need to put a lot more processing power effectively in this, right? I need multiple server class processors to be able to do this. So how do we do that? Well, so here's a really good use case. So I actually pick these for fun. I'll actually pick something and say, okay, what if so think about this paradigm shift. What if I could give, instead of treating the device as kind of the simple device it is today, how can I reinvent the device and give it the power of cloud computing real time? So I can take that actual machine app and distribute it, almost like client server for the devices. So for fun, I actually pick devices and I reinvent them as IoT. So here's a fire extinguisher, dumb tank. No digital, it's got 0 lines of code, 0 CPUs, 0 apps, no automation. How many of us in here, I'd just like to know, how many in here have actually put out a fire with a fire extinguisher? So I think for the 4 that raised their hands, one, you probably were in a panic situation when you had to use it. So one, you had to probably struggle just to find where it was. And I actually did some research on, it actually turns out that most of us who are not trained professionals in putting out fire, we will typically expel 80% of the tank before we even put it on the fire, out of panic. We don't know how close to stand, how far to stand. We don't know what kind of tank it is for what kind of fire. In fact, I looked in the hotel, and all the tanks are just water tanks. I'm like, really? Wow. So if it's an oil fire, forget it, right? So imagine, like in our telematics in our car, if you could actually have a fire extinguisher that when you actually point it at the flame, it actually is giving you navigation instructions on how close to stand or how far to stand away. And if you're not pointing on the flame, like most people would just squeeze the release, and they're not even pointed, so they shoot over here when the flame's over there, that the fire extinguisher doesn't even allow the expellant to be put on the flame until you're actually pointed on the flame. So it's like giving you target-aided, recognition capability that helps direct you to that function, and even can control the flow of how much to put on the flame to maximize starving the flame of oxygen, because actually putting out a flame is actually all about starving the flame long enough that you cut its oxygen supply and it goes out. So imagine a fire extinguisher where you give it a little bit of onboard processing power, but over the network, you're actually connecting the servers, let's say in an airport, where the actual applications for controlling fire suppression are being networked, and it's almost like client server for the machines, right? So now I could actually have applications such as FireWatch that actually knows how to look at a fire and how to put out a fire, right? Much better than I do. I can have auto sweep that actually gives me turn-by-turn instructions on how to actually aim at the fire. It's telling me over the little speaker, stand closer, stand closer, stand closer, and giving me, just like a coach, just like a fireman helping me to put it out. Well, this modestly improves fire suppression, makes putting out fire 3 times safer and 3 times more effective than that old dumb tank. And the key is, if you think about it, let's pick an airport. There may be 100 fire extinguishers in an airport, or 200 of them. Well, if I gave that kind of intelligence and put it on the fire extinguisher, this would be a $2,000 fire extinguisher. But by having it connected to the server and having a server that's capable of running 2 or 3 concurrently, right? I don't need to run 200 concurrently. But if I could actually give that one time when that one fire extinguisher needs to be used, if I could give it the power, let's say, of 12 Xeon processors and a big database and the ability to actually give you that kind of automation, now effectively for $10.99 a month, I can monitor these fire extinguishers. I can actually have that kind of capability always there on ready. And when you need a really smart fire extinguisher, you can have a really smart fire extinguisher. So this is about real-time tethering the power of that cloud processing power and big server processing to the device edge. This is all about making the devices smart. And then lastly, this is actually this is an actual startup in the US that's actually building a physical therapy exoskeleton. So I get injured, I have surgery performed on me. Today, what do? We get a tennis ball in our crutches and we go meet our physical therapist, and we get a few minutes of training, and then we go home and we try to practice it, right? So this is a machine where you actually strap yourself in. A physical therapist actually gives it a flight plan on how to conduct your therapy, and the machine lifts you up and physically moves you, programmed on how to rehabilitate you based off of your injury. Combine that with sensor technology, I can actually get the biofeedback that tells me your pain level, your comfort level, and I can even track visit to visit how you're performing and change the prescript dynamically. To be able to do that kind of human emotion in bioanalytics, right? We're talking about massive capability on the server side, right? You'd never be able to put enough processing power into this basically computing pack on the back. So you're going to want to go client server and have the power of cloud computing helping to do this for you. Revolutionizes physical therapy. Now just take that to fitness and imagine fitness machines where for $9.99 a month you have a professional fitness coach that in your exercise exoskeleton gives you instructions on how to perform, and the machine itself is just really moving you and adjusting you to the optimal fitness. So that's IoT. That's 25 minutes on what we believe is a pretty exciting next wave of computing, and I think the rest of the day we're going to have a number of other follow-ons that tie into this message. Okay?